All right, let's get started then. So my name's Jon, I'm a VP of Engineering at Canonical. I'm here to talk about the Terraform provider for Juju that we've recently invested in, and talk a bit about why that might even be a thing that you want and how you might go about using it. So firstly, Juju is really all about managing applications throughout their life. That's its big pitch sell. It's not about managing the minutiae of, I want to deploy this VPC, create this Lambda function. It's all about operating applications competently from the point where you deploy them, but more importantly, onwards throughout their life. So that might be managing updates, it might be rolling out new features, it might be aiding the integration of applications that allow you to compose lots of different bits of open source into bigger solutions. It's really about fundamentally trying to make SREs' lives a little bit better, right? Like page people out of bed a bit less often because there's something taking care of the software that's supposed to be running in production. It's not really for all of these sorts of things, right? So there are plenty of tools out there that will give you lots and lots of very fine-grained control over your cloud and allow you to make all your own mistakes, expose every single attribute, SKU, setting, config option. So deploying Lambdas on AWS, creating DNS records on DigitalOcean, manage databases on Azure, whatever it might be, right? Deploying machines with gold images. There's a whole plethora of things that you can do with the likes of Terraform and Ansible, or just by calling their APIs or using their command line clients. And Juju isn't really for that. It does a lot of manual provisioning kind of under the hood. So when you say to Juju, go get me a Postgres or deploy me a MongoDB or deploy the observability stack, it knows how to get the resources it needs. It will go and get you a virtual machine, put that in a subnet, create a security group, or it will deploy a pod on Kubernetes. But you would never use Juju as a sort of general resource provisioner to just kind of go and deploy a VM. You would normally only do that in the context of deploying a particular application that you might need for your use case. But it's pretty valuable to be able to do both, clearly. You don't want to have a setup where you fundamentally can't operate the applications because, say, your organization uses an organizational-wide VPC, or it has some particular compliance regulations, which means you need to use some particular setup with DNS or whatever it might be. The ability to deploy applications with the Juju the way it wants, but inside a kind of corporate framework or alongside existing infrastructure as code setups, is pretty important. It's a perfectly valid ask, right? You may also want to run some of your applications with Juju, say a charmed Kubeflow or a manage Postgres through our charms, but you might also want to use Lambda functions on AWS, right? Like the two aren't mutually exclusive. So that's where the Juju Terraform provider comes in. So this is a project that we undertook over the last 6 months. We did it with the Juju team and a third party called Open Credo, who are a kind of London-based consultancy who have done a bunch of work with Terraform alongside Oracle and AWS and others. It's now going to be a supported part of the Juju ecosystem by the Juju team, and right now, it sort of assumes the presence of a Juju controller. So if you have previously bootstrapped a Juju controller and your Juju client has access to that, then you can get started using the Terraform provider straight away. As for what it can enable you to do, right now you can create models, you can deploy charms, you can configure charms, you can create relations, and you can also create cross-model relations, which is something that you've previously not been very easily able to do kind of through scripting and infrastructure as code. So our existing bundles kind of infrastructure allows you to specify a number of charms you want to deploy, how they should be configured, and relations sort of within that bundle. But combining lots and lots of different charms together across models, across different clouds is something you've not previously been able to do, and the Terraform provider would allow you to do that. It also means that you can combine different bits of cloud infrastructure into a Juju deployment. So let's say, for example, you're deploying an ingress controller with Juju, and that ingress controller needs to know the public address of a load balancer that you provision on AWS. Well, you can use Terraform to go and provision yourself an AWS public IP and a load balancer, and you can then feed the kind of output from that, right, the IP address that it actually got in real life, feed that into the config for a charm, and Terraform's dependency engine will do all of the work for you to make sure the load balancer was brought up first, it knows what the IP address is, and then it configs the charm. So all of the kind of goodness that you get from Terraform in the sense of its ability to know which resources are dependent on which resources, you get for free here too. It also means that if you have an existing infrastructure as code set up, so you're already perhaps deploying off the end of a CI pipeline for AWS or for Google, you can now use this to manage applications as well. So if you want to introduce a big Kubeflow bundle or our observability stack or just a managed database, then you can now do that alongside all of your existing Terraform configurations on any of the supported clouds that Juju works on. It'll also help in the kind of hybrid cloud situation where you've got some stuff in your data center, some stuff in AWS, again, you can kind of use Juju to use Terraform to provision resources and kind of feed them to Juju, right? And configure them how you wish. We're going to build on this principle, so we're going to get the ability in the future to provision machines, say, with a gold image on AWS. So if your organization mandates a particular image, that's not something that you can make use of with Juju right now, but with the Terraform provider, you're going to be able to provision that machine with the exact SKU that you want, all of the kind of usual settings that you would want to tweak, give it an image, and then essentially use the Terraform provider to add that machine into the Juju model and then deploy charms to it. So it unlocks a couple of different workflows that previously have been kind of quite manual. Fundamentally, I think this is going to be the replacement for Juju bundles. So we're heading towards stacks in Juju, which are a kind of much more encompassing way to deploy lots and lots of different applications that need to talk to each other. And these are, a Terraform file for Juju looks a lot like a bundle right now. It's a list of charms, a list of configs, some relations. The benefit is Terraform keeps some state. Whereas with bundles, you get kind of no bundle state, right? Once you deploy it, the notion of the bundle kind of dissolves and you've just got a bunch of charms in the model. If you combine Juju with Terraform, then you have a state file that says, okay, well, the last time you poked me, I know that I deployed these 10 things with this config and these relations. Before you go ahead and press the button, this is the diff that I think that's going to happen when you apply again. So you get, if you want to, for example, upgrade the revision of all of the charms in what was previously a bundle, you can kind of make that work with the Terraform provider. It's a bit of a workaround, but it opens up a few different workflows for people to use. I still think the biggest one for me is the kind of fundamental integration with other cloud resources, right? Because once you've deployed a resource with Terraform, you can essentially refer back to the various attributes of that resource as it exists in real life. Later in your Terraform kind of declaration, you can now use that to feed charm config and various other Juju model config options, for example. So I wanted to do a live demo. I'm not brave enough, and this is only supposed to be a 10-minute talk, and I thought deploying lots of stuff on Juju in a 10-minute talk and also having something to say probably wouldn't be such a great idea, so I have it recorded. But to kind of prove this point, I'm going to do a demonstration where we get a Juju controller that's bootstrapped on microcates. We're going to deploy Zinc in one model. Zinc is a kind of lightweight Elasticsearch alternative that's been developed by a software engineer at Amazon. So it's a single Go binary. It maintains compatibility with the Elastic API, but it's just a kind of much lighter weight and quite new project. I've been using it to kind of experiment with some of the observability stuff in Juju. It's quite a nice kind of workload there. And then in another model, we're going to deploy Loki, which is Grafana Labs' kind of log aggregation tool. We'll deploy Prometheus for scraping metrics. We'll deploy Grafana. And then we'll also deploy Parker, which is a continuous profiling tool about which I have a talk later on. And we'll show how essentially you can deploy all these things in different models, form relations across them, and at the end of it, you end up with Zinc in one namespace and all of the observability tools automatically configured, preloaded with Grafana dashboards, all the metric scraping set up, continuous profiling working, essentially by just typing Terraform apply at a machine where you have access to a microcates. So we have a video. So hopefully that's clear enough. So walking through this, we'll start by just bootstrapping a controller. So this is a standard process, bootstrap Juju onto microcates. That nice little error that you see there has gone away in Juju 3.0. I recorded this a few weeks ago. Now we're going to just take a look through a Terraform file that I put together. So you configure the provider at the top, doesn't really take any input, it just reads the config from your local kind of home directory. You can see defining there a couple of models, a couple of applications, so Grafana Kates, Prometheus Kates. You can specify the channel from the store you want to use. That's setting up some integrations there, so relations between two apps, and then creating offers for cross-model relations. So anyone who's familiar with Terraform, they should look pretty familiar, right? There's a bit of Juju language in there, but fundamentally it's just a standard Terraform provider. We can run Terraform plan. It goes away and speaks to the controller and says, okay, I've got a bunch of stuff to add, and if you run Terraform apply, it'll go ahead and do that. So now it'll run through, it'll figure out what order to do things in and make sure all the charms are stood up before it starts creating cross-model relation offers and that kind of thing. So you can see there it's created a couple of models, deployed a bunch of apps. We'll just wait for that to complete. Okay, so if we then take a look at Juju status, well, Juju models first, you can see you've got two models created there, the monitoring model and the Zinc model. And then we're going to take a look in the monitoring model and see what it's created. So you can see there, Grafana, Loki, Parker, Prometheus, a whole bunch of relations. It's kind of still bootstrapping itself at this stage. And then we can do the same in the Zinc model. And you can see the cross-model relations there at the top under the SaaS section. And then slowly, as it starts to come up, you can see the charms end up in active idle, all the relations are formed, and you've essentially just deployed 5 or 6 apps in one command across 2 different models, formed a bunch of relations, and that is now all in a Terraform state file. You can manage that as a team if you want to do state files in S3 or whatever it is. And so as you iterate and add more applications, you can just kind of build on that, and Terraform will keep track of it all for you. At the end of that, and so there is a link at the end of this talk, you end up with a Parker dashboard where you can profile Zinc and see how it's using its memory and creating Go routines. There's Grafana dashboards all pre-populated, which is kind of a feature of our observability stack. But fundamentally, in one command, you can stand up this entire thing. That was kind of the point. So the Terraform provider itself is also open source. It's in the Juju GitHub org alongside Juju itself. We were collaborating with a third party, like I say, but now that's a kind of first-class supported thing by the Juju team. It's relatively early in its life, so like I say, at the moment, it's create models, deploy charms, configure charms, create relations. We are going to add more features. I'm very open to suggestions for it. I think we should probably find a way in the future to kind of streamline the process of actually bootstrapping a controller somewhere. You can kind of hack it together now with provisioners in Terraform, so you can create yourself an AWS EC2 machine and kind of run a script to install Juju and bootstrap itself, but I'd like to streamline that. And I'd also like to work on kind of adding arbitrary machines into the Juju model that allow you to place charms on those machines with Juju afterwards. The documentation is all set up. This is all published in the Hashicorp store, so it's a first-class provider. If you just use the Juju/Juju in the provider statement, it'll go get it from the Hashicorp registry, and all the docs and like auto-generated docs in the right format are all there too. So yeah, that's pretty much it. This was only a lightning talk. I don't know why it was in a half-an-hour slot, but I'll take any questions if people have got them. Sure. Hang on a minute, I'm supposed to give you a microphone. How's he catching? I hope it's better than my throwing. There's a litany of throwing and catching failures there.
Right, so you did mention that you could get a diff in the state of the Terraform model. What I'm interested in is, can you upgrade the charms, and how much you would trust the Terraform to upgrade your charms one at a time in a high availability cluster setup?
So that's an interesting question. So I probably wouldn't use Terraform to upgrade charms. So you could theoretically like specify a revision for a charm and then sort of change that revision and run
Yeah, but it
Terraform
would just apply to all of them, right?
Yeah,
Okay.
I guess it depends on the application, right? If you're going to, your mileage may vary. We're pretty early at this point. I think it'd be interesting for us to figure out a way to kind of integrate that a bit nicer, because it would be a bit brute force, right? It would be issuing essentially individual API commands to Juju to say like refresh this charm, refresh this charm, refresh this charm. But there is a way of, you can kind of manually hack the dependencies in Terraform, but it's not generally a good idea.
Well,
right?
the manually hacking, you could do it without a Terraform, so it doesn't. I was just
Right.
curious if you have the
But
option.
you can run Juju refresh in the right order and then kind of reconcile that in the Terraform state and carry on as you were. So that's another option.
Thank you.
Any other questions? Cool. Thanks very much.